Okay.
Thank you. So basically, yesterday we talked about the remainders theorem. And for the factors theorem, it's like I mentioned yesterday, it's just an extension of the remainders theorem. And the remainders theorem simply says, if Px is a polynomial, and you are to divide by x minus x plus a, then the remainder is f of minus a, isn't it? We can actually prove that. So I'm going to try to explain the formal proof of that. So recall that our polynomial p of x is equal to what? The quotient, right? Talk to me, please.
Yeah.
The quotient,
the divisor
plus the remainder. Now, if your polynomial is divided by x plus a, so which means this is your divisor, okay, then our p of x is simply q dot x plus a plus r. Is that not?
Yeah.
So let's see then p of negative a. It means we change x to negative a, isn't it? It's simply q of negative a plus a plus r. What do you notice?
The a and negative a cancel out.
So that gives you a zero factor.
Oh.
And that makes this zero. So
Oh.
Oh, that's how you do it. Oh. Makes sense.
so that is the formal way to explain that idea. If you want to show this. It's just from the definition, basically, and substitution. Alright? So this is why we say that is a remainder. Okay, so this is the proof of remainder theorem. So we can say this is the proof of remainders theorem. Because I might give you an activity that has to do with prove that something. So this is how you think about that. You present that. Now, if the remainder is 0, then that divisor must be what?
The factor.
A factor. And that is the factor theorem. Now, we have a factor if r is equal to 0. That is, if p of minus a is equal to 0. Okay? Hence the formal statement of the factors theorem. Therefore, if p of x is a polynomial, then x plus a is a factor of p of x if what happens? If p what? Come on, we've been talking about it from the beginning. I expect a straightforward answer.
If p negative a
If p negative a
is 0.
is equal to 0. And that is what we are going to be using in these last few minutes. Okay? So the first question I want you to do use the factors theorem to determine whether this is a factor. So I want you to do from exercise 5G or 5G network. I want you to take question 1A, 2A, page 127. Do I need to put a page? Yeah. Let's put the page. 127 to 128. Question 1. I think A is usually simple, isn't it? So I give you the difficult ones. I'm so mean. I love being mean. sit down so you can see the screen. Sorry. Sorry, Miss K. It's okay.
So, Mr. Daniel, what is the factors theorem?
What?
The factors theorem is the remainders
Oh,
theorem,
I believe
but
so.
0?
I don't understand your question. You told me something that was writing here.
Yeah.
So this is the factors theorem.
Oh, okay.
Right. I just said this is a proof of the remainder theorem. Okay. It's called the factors theorem. Maybe I write that. Okay, better? Eight. So that's all.
Mr. Daniel, what time should I remind you of the task?
Anytime tonight. I'm out of school by 4:20. So today's Thursday. I'm seeing someone at 5 o'clock.
7?
No, 5 to 7 I'll still be in Taipa. No, 5 to 6 actually. So by 7:30 I'll be home. So then I'll be able to work on extra stuff. Thank you. This was what I was asking you, fundamental theorem of algebra. Alex. The name I asked you to give me. Okay. We talked about it in complex number, isn't it? So we'll talk about it here again. You're confused? Do you need me to show an example? Of which one?
This is the first one.
First one.
No, but then, you just use the remainders theorem, see if it's 0.
If it is 0, that's all you have to do.
Prove it. You say, that's factor. No.
Oh.
You say use it to determine if it is a factor. So basically you find the remainder.
Yes.
Oh, the remainder is equal to f of 2, for example, for the case of the first one.
Yeah.
F of 2. So is f of 2 0? If it is 0, then that means x minus 2 must be a factor. If it is not 0, then it is not a factor. That's the whole idea.
Oh, okay.
Okay, look at the statement of this factor theorem. X plus a is a factor if the remainder is 0. That's why we started with, we have a factor if the remainder is 0. This is what you are checking.
Oh, okay.
Okay?
So you first find out.
You do, just like you are doing remainder theorem, but your goal is to see if the result is 0 or not.
Okay. Okay.
In general, your remainder is the final answer, isn't it?
Yeah.
How? Do you get 0?
Yes.
Okay. So since the remainder is equal to 0, then it is a factor. Something like that.
What's the symbol for since? Is the
The
upside down
reciprocal
therefore,
of,
right?
yeah, of therefore. Kelly's so busy, she doesn't know what I was doing. She's always in that world. So that'll be all. The rest of the class is just practice. Thank you.